Hello, good morning viewers. In this tutorial, we are going to show that the left and the right hand side of this trigonometric expression are equivalent to each other. So if you are new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload a new content, and don't forget to share to your learning colleagues. Don't forget also to hit the like button. But it is always recommended to start with the more complicated side. Therefore, we are going to show that the left hand side is equivalent to the right hand side. Well, one thing you should observe here is that we have two double angles for sine and for cosine. So let me express them first. Sine 2 theta is equal to 2 multiplied by sine theta cos theta. This is how to simplify double angle for sine. For that of cos, if you have cos 2 theta, it is equal to cos squared theta minus sine squared theta. So instead of this and this, we are going to substitute these two equations respectively. So let me start with sine to the top. You can see we have sine 2 theta. So instead of sine 2 theta, I'm going to write 2 multiplied by sine theta cos theta. So 2 multiplied by sine theta cos theta. Then we have minus cos theta. The whole of this divided by, we have sine theta. Then minus, this minus is going to affect these two terms. So we have minus cos squared theta. The minus will turn this to positive sign. We have sine squared theta. From the top, you can see we have cos in common, so we can factor out cosine theta. So this is equal to cos theta multiplied by 2 sine theta minus 1 if you factor out cosine theta. And to the bottom, one thing you should know is that cosine squared theta can be written as 1 minus sine squared theta, because sine squared theta plus cos squared theta is equal to 1. Therefore, cos squared theta is equal to 1 minus sine squared theta. So instead of cos squared theta, we are going to write 1 minus sine squared theta. So we have sine theta here. This minus is going to affect these two terms. So we have minus 1, then plus sine squared theta, and we have another sine squared theta here. Sine squared theta. This is equal to cos theta multiplied by 2 sine theta minus 1. To the bottom, you can see we have sine squared theta, another sine squared theta, making 2 sine squared theta. So let me write it here, 2 sine squared theta. Then we have another sine theta here, plus sine theta, and lastly we have minus 1. Our denominator is a quadratic expression now, written in terms of trigonometric function. And we can factorize it as 2 sine theta minus 1 multiplied by sine theta plus 1. If you multiply the two factors together, you shall obtain this back. So this is equal to cos theta multiplied by 2 sine theta minus 1 divided by sine theta plus 1 multiplied by 2 sine theta minus 1. This is the factorized form of this. If you should multiply these two together, you must get this back. From here, you can directly see that these two terms are exactly the same, so they cancel. Finally, what we have is nothing but cos theta divided by sine theta plus 1, which is exactly the same thing as the right hand side of our equation. This is exactly what we have. 1 plus sine theta or sine theta plus 1 is commutative. 1 plus 2 is exactly as 2 plus 1, and hence proved. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.